Right guys, we're going to look at geometric sequences. Now remember, in terms of formulas that are actually given in the formula booklet, you're given that the sum formula is a lots of 1 minus r to the n over 1 minus r, and you're given that the sum to infinity is a over 1 minus r. Okay, but you just need to remember that the typical rule for a geometric sequence is ar to the n minus 1. That will find you, that's basically like your nth term, so that will find you any term in the sequence rather than a sum or a sum to infinity. So a geometric sequence has a first term a and a common ratio of 3/4. Sorry, that's the printer. The sum of the first 4 terms of the sequence is 175, so I know the sum to 4 is 175. First thing it wants us to do is show that a is 64. So using the 2 pieces of information we were given and the sum formula this time, we're going to find out what a is. So I get 175 is equal to a lots of 1 minus 3/4 to the power of 4, since this was the 4th term we were doing, over 1 minus 3/4. So 1 minus 3/4 is going to give us a quarter. So if I times up by a quarter, I get that this is 175 over 4 is equal to a lots of, and if you do 1 minus 3/4 to the power of 4, you get this nice, delightful, horrible looking fraction. Again, we're going to keep everything in nice exact forms, and then all I need to do, so that obviously worked out to a quarter, and all I did was times up by a quarter. From there, we're going to divide by our lovely fraction. You get a equals 64, which is what they asked us to prove. So that's it, done. Part B says find the sum to infinity of the series. Well, sum to infinity is a over 1 minus r. So in our case, that is 64 over 1 minus 3/4. That is going to give us a sum to infinity of 256. And part C, find the difference between the 9th and the 10th term. So remember, the 9th term is ar to the 9 minus 1, so ar to the 8. And the 10th term is ar to the 10 minus 1, so 9. And we want to find the difference between those 2 terms. So I'm just going to work out 64 times 3/4 to the power of 8. And we're going to do 64 times 3/4, that was a 3, sorry, to the power of 9. And then we're going to do 1 subtract the other. So 64 times 3/4 to the power of 8. And 64 times 3/4 to the power of 9. This one doesn't come out as a fraction, it comes out as a lovely long decimal. Okay, so all we're going to do, this one works out at about 6 point something, so we're just going to do the difference between them. This one, take away this one, is 6561 over 1024 minus our last answer gives us a difference of 1.602 to 3 decimal places. And that's it. So if we look at the second question, you've got a geometric series, has a first term a, which is 360, common ratio of 7/8, giving your answer to 3 significant figures where appropriate. 20th term of the sequence. So remember, 20th term means we're using the general term in a sequence, ar to the 20 minus 1. So you're doing ar to the power of 19. In our case, that is 360 times 7/8 to the power of 19. That gives us, and to 3 significant figures, 28.5. We're then going to do part B is the sum of the first 20 terms. So that's our sum formula. So the sum to 20 is a lots 1 minus r to the n over 1 minus r. So I get 360 lots of 1 minus 7/8 to the power of 20 over 1 minus 7/8. Again, it's just something you completely type into the calculator. You're going to get 2680.678 and so on. They wanted 3 significant figures, so 2681, sorry, 2680, 3 significant figures. And then part C is the sum to infinity of the series. Now, sum to infinity is a over 1 minus r, so we're just going to do 360 over 1 minus 7/8. You get 2880, and that's it, we're done. Okay, hopefully that one's not too bad. Just remember, the one formula that seems to keep being forgotten at the minute is that in general it's ar to the n minus 1 to find the nth term of a geometric sequence. So if that's you're looking for the 4th term or the 7th term rather than a sum. So just be very careful to make sure you read the questions.